Yeah. So guys, first start with the topology. The topology it's simple only. Like here we have lines. This can be a GSM mobile, like like we work on the CPE side when on cellular. That could be a cellular modem which connects to a BTS here. This is called base station, and then it's all ISP devices. Similarly, we can have CPE side where we have modem, DSL modems, or we can have some normal Ethernet cable, Ethernet as a L1, L2, which connects to LAC. So if you understand BRAS properly, it will be easy for you. Means half a part it's covered in BRAS, PPPoE, and PPP. In BRAS, we call that BRAS when PPP terminates on when PPPoE and PPP terminates on the same device. But when PPPoE, see PPPoE is terminating on LAC. This device is called as LAC, L2TP access concentrator. When PPPoE terminates on a device, it is called as LAC, and it forwards the PPP frames to LNS. LNS is L2TP network server, and the PPP will actually terminate on the LNS. So that's the difference between, first of all, you need to understand the difference between LAC and BRAS. So LAC is what? Where PPPoE terminates, and BRAS is where PPPoE and PPP both terminates. Coming to next slide, here we have a PC. It could be a DSL modem also. So generally we have modems only, and it connects to a LAC, and LAC will be connecting to a radius server, depending upon the customer's topology, may or may not be. Uh, then LAC will actually open a tunnel with LNS, L2TP tunnel with LNS, and LNS will be for sure connecting to a radius server or AAA server. So I'll briefly explain how VPDN works. Then in the next slide, we'll understand how this L2TP tunnels or VPDN tunnels forms between LAC and LNS. So first of all, a call is set up. That is, client calls the LAC using a modem or an ISDN card. So here you can also have in between you can have like ISDN network in between or a PSTN network in between. It could be if it's a DSL modem, it could be a DSLAM in between, or if it's a Ethernet, it will be normal like connected to a switch and this LAC. Or if it's a cellular device, it will be a BTS in between, a base station, a tower, you can say normal tower that you see. So firstly, a call is set up. Then second, a PPP negotiation starts between client and LAC. So in PPP, only LCP options will be negotiated. LCP options like you have MRU. Um, Second is what type of authentication protocol? Is it PAP or is it CAP? It could be some more that they are like one is MRU authentication. Then a CAP will be negotiated. We are on the third step. The CAP or CAP authentication will happen between PC and LAC. So a LAC might be having a local authentication database, or it can go to a radius server. So it all depends upon how customer has configured. Generally, it would be a radius server only. So it will send a access request message, and an access accept will come back. Now, a CAP challenge will be sent by LAC, and client will respond with its username. Username will be having a domain name and a password. So I'll show you the configuration one. Uh, See this CPE site. The CP side is exactly same what you saw in the BRAS training. It's exactly same here. The difference, only the new thing here you are learning is this one, this part. That's it. All other things we have already learned in BRAS. This is LAC side and this is LNS. This is a new thing that you are learning today. All other things we have learned before. So this is called as domain name, client one or client two. It should be configured on the LAC side. The if you see here, the client is sending its username at the rate client one. It should match here. Once the domain name matches in the VPDN group, LAC will get to know it's a L2TP, it's a VPDN client. It's not a BRAS client, it's a VPDN client. Because in customers environment, a device will act as a BRAS, it will be acting as a LAC, or it will acting as LNS. It could be anything. You need to understand the exact topology based upon the configuration. Yeah. So the client will respond with its username, with a domain name and a password. LAC will check whether the client is a VPDN user or not. If does this, it does this by using its local VPDN or configuration or contacting AAA. When the client is a VPDN user, LAC brings up a L2TP tunnel with LNS. Now we are at the sixth step. So once the leg gets to know that it's a VPDN user, it opens a tunnel with LNS. So based on the name from LAC, LNS checks if a LAC is allowed to open a tunnel or not. Also, LNS and LAC authenticates each other. It could be using a local database or it could be a AAA server. I'll show you that the configuration. Yeah. So see here, this is a local name, LAC1, and here it says LNS. LNS will check whether this device, whether the LAC is allowed to open a tunnel or not using this name. It should match here. The local name and the terminate host name should match on both the sides. Also before opening a tunnel, they will authenticate each other. This is authentication here. LTTP tunnel password. Just go. So now say the tunnel is up, and now the tunnel is up between both and between both LAC and LNS, and several VPDN sessions can be carried in this tunnel. Hundreds of sessions over one tunnel can be established. So now what happens is this LAC, like for a client with a username, the VPDN session is triggered from a LAC to LNS. There is one VPDN session per client. Now LAC will forward the LCP options to LNS that it received from the client along with the username and the password. So here we are at the ninth step. The LAC will forward the LCP options that all were negotiated between the client and LAC. Now LAC will forward those LCP options to LNS. LNS will clone a virtual access template from a virtual access interface from a virtual template specified in the VPN configuration. LNS will authenticate the client now by contacting its local database or radio server. Uh, the LNS will send a chat response. Uh, with this one, we are at the 12th step now. So it sends a so the LNS will send a chat response to the client. IPCP phase is performed and then route is installed. That all complete PPP. That first is LCP, then LCP and IPCP phase. And now the PPP session is up and the running between the client and LNS. So this is how the brief overview of how this works, the complete VPDN process works. Is it clear? If you want me to repeat any step or any doubt in this. Okay. So are we good to proceed further? Okay. Um, Now coming to how this L2TP tunnel is established. So L2TP will be established between LAC and LNS, right? So it uses L2TP uses UDP port 1701. So now the first so once the once the PPP frame once LAC forwards a PPP frame, or once LAC gets to know it's a VPDN user, it will forward the all LCP options, and it will first of all open a tunnel. For the first time, if there is no tunnel between the LAC and LNS, it will firstly open a tunnel. First packet or message that LAC sends is SCCRQ, that is Start Control Connection Request. I'll show you that in the packet capture also. Yeah. So first of all, see this SCCRQ is sent. So it will be having some AV pairs, or it will be having tab challenge, and it will be having a local name as well. So if you see here, it says control message. Um, it says control message type is start control request, and here you can see the host name, that is LAC1, which we have configured on the LAC side. Yeah, that's some important things you can check in this packet. Once the LNS receives SCCRQ, it will respond with SCCRQ, that is start control connection reply. Uh, uh, that it will also be having a chat challenge, or you can say the tunnel authentication key. You can say that we have configured as Cisco here. Uh, it will also will be having a local host name as LNS, and they will and both the tunnels, both the sites will actually negotiate some window size. This will for how much packets can be sent per second. It's I think 1,000 packets per second. I think something like that. So it's a 1024 something. Yeah. This one is, and that will respond with SCCN, that is start control connection, uh, and the LNS will respond with ZLB. ZLB is just used as an acknowledgement. It's zero length byte. It's zero length byte just used for acknowledgement that yes, we can now establish a tunnel. And also the main key is they will start with tunnel ID, is 34979. This 34979 ID will be on the LNS, and on the LAC it will be 3465. Now coming to this one, ICRQ, these ICRQ, ICRP, and ICCN. These are session control messages. Once the session is formed, these messages are exchanged. Is ICRQ is incoming call request that the LAC will be sending out, and LNS will respond with the incoming reply. And once the parameters are negotiated, once the parameters match, the LAC will send out ICCN, incoming call connection. Yeah. Now let's check the configuration one. So first of all, it says VPDN enable. Uh, it's like it's mandatory to configure this VPDN enable. It's like you are enabling a VPDN service on the device. You are now configuring VPDN group. Any number you can configure or any name you can configure. Request dial-in. This VPDN group is it actually initiates a tunnel. This means it's initiating a tunnel. It's dialing out. And then the protocol L2TP, you can have protocol TPTP, you can have L2F. L2F is it's an old protocol. We generally don't use it. We will not see L2F nowadays. Then we have client one and client two. Uh, this initiate to IP 6.6, it's LNS IP. LNS loopback IP you can give, or you can give the interface IP. You need to mention a local name for this device, or this local name will be per VPDN group. There could be multiple VPDN group, and all VPDNs could have different local name. And this L2TP tunnel, this authentication, just to authenticate each other. Almost the same configuration is on the LNS side. Here it says accept. It's accepting a call, and protocol is L2TP, and it's terminating a tunnel from the hostname LAC1. So LAC, this local name should match on both the sides. And also you saw that in a BRAS, on BRAS we configure pool and username for authentication. But here on LNS we'll be configuring username for the subscriber authentication, or it could be on the AAA or radius. And a pool will be configured here to assign an IP address. In BRAS, it would be in BRAS when it's a BRAS case, it will be on the LAC side, or you can say a BRAS only. Now, see, once the sessions are established, PPP frames will be exchanged, all PPP authentication will take place, and IPCP will be there, and IP will be assigned to the client, and then it will be L2TP data packets. CDN means connection disconnect. CDN, if it was CDN means session is disconnecting, means session is going down, and that will be just acknowledgement. It's just an acknowledgement for that. Stop CCN means stop CCN is for the tunnel disconnection. Once tunnel goes down, a stop CCN message will be sent, and it's ZLB then. ZLB will always be there. It's like once the tunnel is established, once L2TP tunnel is established, hello packets will be sent on both the sides, and for hello packets there will be a ZLB sent. Like um, I actually stopped very quickly for PPP. Okay, this you can see here. This control message CDN. CDN means the session is going down. And in packet capture, you can also see why the session went down. So here it says call disconnect notification. In the result error code AVP, you can see locally generated disconnect. So I think when I captured this, I think I shut down the client side. I shut down the dialer interface on the client side. It says locally generated disconnect. Oh wait, one second. Okay, yeah. And now if you see here, stop CCN. This stop CCN means the tunnel is going down. You can see the result error code here. It says no application or session timer expired. So when there is no session on the tunnel will automatically go down. So there should be at least one session for the tunnel to be up. Otherwise, if there is no session, the tunnel will go down as well. Yeah. So guys, is it clear till now? So if it's clear, I'll go on the next slide. Before showing the commands, I'll tell you the multi-hop L2TP. So yeah, multi-hop L2TP, its concept is same. It's just that LTS is in between. LTS, it's L2TP tunnel switch. What it does is I just switch the tunnel. First of all, the tunnel will be established between the LAC and LTS. LTS will just will switch the tunnel and will create a new tunnel with LNS. So there will be a new tunnel formed between LTS and LNS that will be carrying the same PPP frames that are being forwarded by the LAC. So it's nothing much in this. It's just the configuration if you see. It's just a simple one command here, PPD and multi-hop. Otherwise, everything will be same, almost same. One VPDN group or VPDN group, if you are saying a VPDN group means you are configuring a tunnel. So you see a VPDN group from LAC. So there will be a VPDN group configured established between a LAC and LTS, and it says another VPDN group or a tunnel will be created between LTS and NLS. Otherwise, the configuration is same, almost same. Now check some commands that we have, commands and some troubleshooting. So, so let's see some. Uh, I'll show you the configuration here. On this, so this is R1 is the client side. So it is sending out with the user one as a username, and the domain name is client one. Similarly on R2, which is another client. So then interface. So it says its username is user two, and the domain name is same client one. And R4 here will be receiving some PPPoE packets, and PPP will be negotiated between this LAC. L4 R4 is a LAC, and R4 once authenticating, it will send it will forward the PPP frames. Before forwarding, it will establish a tunnel, and it will form a session, and then PPP frames will be encapsulated in that tunnel protocol, and it will be forwarded over to LNS. So this is a command to check VPDN tunnel. Uh, this remote name you can see here, LAC1. State should be established. Remote address 2111. 2111 is Ethernet 11 IP address. And this L2TP, it's what we have configured here. L2TP VPDN group 100. Here we have configured VPDN group 100. VPDN group number or name is local to the device, so it need not to be matched on both LNS or LAC. So here we have two VPDN groups, 100 and 101. So 100 is used to form a tunnel between LAC 1 and this device R6, and the VPDN group 101, it's used to create a tunnel between LAC 2 and this device LNS. Since this R3 is down, so there will be no second tunnel or no tunnel formed between LAC2 and LNS. So to check the sessions, we have 12 to TP session. You can find here the username and the domain name. It's its interface, the virtual access interface that has been cloned with the virtual template interface (VTI). You can get a remote ID. This remote ID it's for the session only, and tunnel ID is same, local tunnel ID here, 1537 135 These are some tunnel commands. Show L2TP session, show VPD and tunnel. You can also do show L2TP tunnel. It's same only. It will give you the same output as show VPD and tunnel. You can see here we have tunnels, one tunnel and two sessions are established. You can do show PPP all to know what IP address has been assigned to the client, or you can also do show subscriber session. And similar command is there show users. So this show PPP all, these all give you almost similar kind of output. Show PPP all and show subscriber session, show users. So if you want to see the configuration for the virtual access interface, you need to do, see since it's been cloned by the virtual template, you need to do show derived. config interface. Mm, Here you can see the configuration of the virtual access interface. Sometimes there will be issues with the that the virtual access is not able to clone with the VPI. Then we can run some debugs like debug me template. For now, let's these commands are general commands to show. Most of the times we will do debugging here. So always do conditional debug. I think Badri would have shared with you. If so, always do conditional debugging because there will be thousands of sessions and maybe like dozens of tunnels. For tunneling and sessions, you have debug L2TP events. Packet events is a better command actually. Packet events and debug VPN events. So these two commands, if I run here now, it will generally show what all states it are being there. Like we saw in SCCRQ, SCCRP, SCCN, all these states will be shown in the debugs. And also there is one more debug. Debug VPN event disconnect. It will give you the reasons. It will show you the reason why this. Okay, maybe some of the slapping. You see here, one of the session was flapping. One of the client subscriber was flapping. So we got an error. It says locally generated disconnect, but it will be very general reason. We will not get to know why is it flapping or why this was locally disconnected. It could be due to some authentication issue. Maybe the virtual access is not able to clone with the VPI. Could be any reason. For that we need to do more. So to know the reason for a VPN failure, we have a show VPN history failure. This will give you a reason why it was disconnected. It is locally generated disconnect. See, it's a very generic reason, locally generated disconnect. Sometimes it will not show why, because it would be possibly due to some authentication issue, or maybe I don't think it's authentication issue, it's some DNS issue. Only. Sometimes it happens. Now see, let's discuss some troubleshooting steps or some scenarios where you will like most tunnel scenarios. So one will be tunnel would be flapping. Tunnel would be flapping between the LAC and NNF, L2TP tunnel flapping. So there could be multiple reasons for that. First of all, it could be tunnel configuration issue or authentication issue, tunnel authentication issue. So I had once I had one case where DRF name was mismatched. So on the CLI it was configured in small letters. On the radio server it was configured in capital letters, and that was actually uh, flapping the whole tunnel. And One was, so sometimes in customers environment they will have a configuration pushed by the server or a portal. In one of my case, customer was pushing one configuration from the portal side. The the VPDN group was in the VRF. The customer actually entered one command to upgrade the VRF, that is VRF upgrade CLI. That is for like upgrading IPv4 VRF to multi-address VRF. So there were around uh, four or five VPDN groups. All were in the normal IPv4 VRF. Uh, there was no configuration. First of all, there was no configuration on the CLI. If you do normally, like if I do show that section VPDN, the configuration was exactly same. There was no VRF configure, but that VRF configuration was getting pushed by the portal. So you need to ask two things every time. What are the configuration that are being pushed by the server or portal? So portal was actually pushing IPv4 normal VRF configuration, but on the CLI one, he had one command that I told you to upgrade the VRF. So that was causing a conflict, and due to that, the tunnel was flapping. There could be other reasons for that, like timers mismatch. So timers, like I told you, like we have hello packets, hello packets exchanged once the tunnel is up. So under VPDN group, you can configure that. So always check the timers are equal on both the sides. VPDN group one. So it says LTTP. So first of all, actually we need to configure protocol L2TP, then only L2TP command will work. So L2TP uh, tunnel, hello. We can configure seconds here, and same it's for ZLB. So these parameters should match hello and ZLB on both the sides. So there's one command to check if there any drop on the tunnels, if tunnel is flapping, or is it tunnel flapping due to sessions are flapping. So that's very hard to know whether it's issue with the tunnel or whether the tunnel is flapping due to all the sessions are going down. But most of the cases there will be hundreds of sessions, and at an instance, one of the session will be obviously up. So there's a very rare chance that tunnel is flapping due to sessions. So here you can see if this way ZLB will keep on incrementing. It's transmitting ZLBs. Uh, this receive 9 transmitting. So you need to check the drop counter. There should not be any increments in the drop counter. If there is something, means that tunnel is actually flapping. And for a particular tunnel, if you want to see, you can do with ID and give an ID of the tunnel for a specific tunnel if you want to see. Also, you can do show VPDN tunnel state. Yeah. So just keep on doing this. Include 0, 0. If you see any like sessions flapping, it will actually show you why. Which, just to get to know which VPDN tunnel is flapping. So if you get to know which VPDN tunnel is flapping, you check the local name LNS. So once you check the LNS, you check the once you got the local name, that is LNS, you can find to which VPDN group it's mapped to. So here LNS we know it's mapped to VPDN group 1 or VPDN group 100. In customer scenario, customer will actually configure um, local name on all the VPDN groups. It will be a unique local name. So and also you can see the LAC one here. So you can on both the sides you can check what's the configuration, because there will be like number of VPDN sessions, VPDN groups, maybe like 30, 40, 20. It's hard to find which VPDN tunnel is flapping, to which peer it's flapping. So using this local name and remote name, you can actually find out which VPDN group, which tunnel is flapping. So there is one more way to find which VPDN group or which tunnel is actually flapping. So there is flow counter tunnel all. Here you can get to know the remote IP address. This is another way to find which tunnel or which VPDN group is flapping. And these drops you can see here also. Second thing, if you are thinking that this could be an issue due to tunnel is going down, due to sessions are going down. So there is one more thing you can do here, that is configure VPN group 100. Now you can configure L2TP, um, L2TP tunnel timeout, no session level. So what will this command do? If even if there is no session available, the tunnel will not go down. Tunnel will be there always. Will be up and working always. This is the one way to isolate whether it's tunnel flapping or whether tunnel is flapping due to sessions. And yeah, so for the tunnel flaps, we can run some debugs that are debug LTTP. Uh, so always use here you won't find any specific debugs for a specific for a specific tunnel or a VPN group. You always need to do the conditional debugs. Here you can do packet event. So this command is very useful. So debug LTTP packet event and error. These two packets you can do. And similarly for VPDN also, debug VPDN. Uh, so L2X you will see most of the times you will run L2X. L2X is simply X means here L2F or L2TP. Even it's for PPTP here. It's L2TP or PPTP. Even it's for L2F. L2F you won't see nowadays. So these two, three debugs are there for MQTT session. If there is also one more thing, if there is AAA authentication, we can run debug radius and debug AAA authentication, debug AAA authorization. These two, three more commands are there. Now for tunnel, I think these are the general reasons why tunnel would be flapping. Now coming to sessions, why sessions and how to set the sessions. So there is one general command I showed you before, show LTTP sessions. This one you can see the uptime. It's been up from 10 minutes. The other one is up from 2 minutes from maybe flat. This state, from here, you can get to know what's the current state of the sessions. Again, this is a global command, means for all the sessions it will show. For all the VPTL groups, all the sessions that are under a VPTL group, it will show. So it will say establish to. This command is actually not much used to real scenarios. It will actually say establish two sessions are established here. And if I do transition, here you can get to know this like the session is going from idle to ICRQ. That is request has been sent from has been received from the lag side. The next is ICCL. It's waiting for ICCL. No. So next is after ICRQ, it's ICCL. It's sending out ICCL. Then once it it's not established there. So here it should be one should be established. Or two sessions should be established here. So now it's ready. I'm not sure why this is not. Maybe because yeah, this is actually a transition state. So since there is no session is flapping, that's why we are not seeing anything here. We will see this in the current state. We will see this in the current state. Two sessions are established, and no session is stuck in any of the other states. So for the sessions you have uh, debugs that are debug subscriber, debug subscriber packet, packet event. So debug subscriber packet event and error. For if it's authentication, you can use debug triple A authentication. You can also use debug uh, debug subscriber triple A. What is that command? Yeah, triple A authorization. Period. So these two three commands are there if sessions are flapping. So always use some conditional debugs. Like for session, you can use debug condition, debug condition, username, and here you can give a username. So one is debug subscriber session, and that will be yeah. So debug subscriber packet event is the one command that you can use for once the sessions are flapping. You can use debug triple S, no, not triple S actually. Debug subscriber triple A authorization event. It will actually tell you which authentication list is getting picked and debug radius you can do. So what all AV pairs are being pushed by the radius server, you will get to see in this, and you can do these two commands. Know why a session is flapping. In most of the cases, what I've observed like in cases we got, it will be mostly it will be authentication issue only. And what else? And yeah, and one more thing, you will see some CP utilization causing issues. So it means these sessions are causing CPU issues. So you can do one thing in the configuration, go to VPN group, VPN group 100, and here you can limit the sessions, number of sessions. You can configure 4 sessions. See, maybe per VPN group you can have thousands of sessions. I think 2,000 or 3,000 is a limit. You can limit the sessions. So once you limit the sessions, it will be easy for you to troubleshoot, and the CPU utilization will be less as well. So you can run debugs easily. Means if because debugs are CPU intensive, so if the sessions are less, you can run some debugs as well. And yeah, one if sessions are flapping, maybe due to some cloning issue that it's not able to clone with the cloning will be actually for PPP. So once the session is established, it could be issue with the PPP. So you can do one thing here, like show PPP all, and so once if you get to know, so if the session is establishing, but it's going down due to PPP failure, you can always filter with this. Show PPP all include 0.0.0. It will always show you which sessions are not being established. You will get to know the peer name and all these things you will get to know. And if you are seeing here, in case if you are seeing some sessions are like PPP sessions are there, but not coming into IPCP phase or not establishing, it means some authentication issues are there only. It's nothing with the sessions. It means you are you are reaching the skill 3. So this first 3 states are getting achieved. These three sessions, these three are getting established. That is for the tunnel. Next 3 is for the session, and next is for the PPP. So if you're seeing some sessions in the PPP, you get to know that it's some PPP failure only, some authentication failure only. That's why the sessions are going down. So it would be issues with the radius server, or maybe it would be issues with that PPP or PPP sessions are not able to clone with the virtual template. So for that, you can run one command. Uh, you can run one command that you can run some debug. That is debug me template, even an error. And also you can do cloning. These three are there. You can do these three debugs. You can run these three debugs that will help you out. Why this? Is there any issues with the cloning, or is it an issue with the PPP or authentication? I think I shared most of the things, the important things. I see some configuration with the VRF. I'll share that one document. It's the same configuration is there. The only difference will be uh, under the after this command. After this, here you will see under the VPN group. Here you will see some VRF configuration here. VPN VRF. Even you can configure VRF uh, under the physical interface or even in the virtual template. That depends upon the configuration. You can configure on all of these three. You can configure VRF on all of these three, VPN group, or the physical interface or the virtual template. Or else you can configure VRF only on VPN group and the virtual template. That will also work. So the configuration will be same. The concept will be same for this. There will be a right IP route VRF something. That's all. Some VRF configuration. That's it. Other configuration for VPDN or LDTP all will be same. While I'll share you some documents for VRF. There is one document for VRF configuration. I'll do this. You need to understand this because so first of all, when it's a multi-hop LTP, first of all, understand what's the topology. Ask customer to explain the topology, which one is LAC, which one is LNS, or which one is LTS. So if you understood the topology well, and then it will be easy for you to troubleshoot the issue. I'll share the documents for the VRF and PPTP. PPTP is a very small document. It's easy, and cases are not much for PPTP. So you can go through that document. It's a very small document, just like 4 or 5 commands only. That's it. And the other part is done on the PC, on the laptop. So I think I've covered almost everything that the most all the important parts. Yeah. So, so guys, any doubts here? Any questions? Any doubts? Yeah. So guys, any doubts? I don't remember any other case. Almost all cases were some authentication issue only. You want one was mostly authentication issue, and two was with VRF. Wrong VRF name was getting pushed. And yeah, for PVP, you guys know, right? Debug PPP authentication negotiation, and there will be no PPPoE ending up here on the LNS. PPPoE will terminate on LAC only on our topology, it's R4 LAC, where the PPPoE will terminate here only, and the PPP session will terminate on R6 LNS.
Yeah, it should be good, Pankaj.
Yeah. Okay, guys. So let us know, me or Badri or Srini, if available. So you guys let us know. You can easily practice this on DNS, or if you want, you can take CFME lab. You can configure a radio server also. It will be- Okay, guys. I'll stop the session now and for the day. Have a good day.
Thanks, Pankaj.